Aiko! I think it's really pronounced Iko. Anyone know Japanese? No? I think it's Iko. Laws of jump on windmills. Today the windmill has a 25-foot long blade and is rotating at 8 revolutions per minute. If Aiko or Iko sits on the tip of the blade, how fast is he traveling around the... I'll just look over here. The windmill in terms of part A, feet per minute. Anyone play this game? You can A, you may leave. I'll just play it. Now imagine it in 3D. By asking how fast is he traveling around the windmill, what are we looking for? We know the angular speed. It's making 8 revolutions per minute. So we need the linear speed. So we need V equals S over T. Oh, I just gave the wrong formula. Now I have to edit all that out. Careful editing. We need R times omega. There we go. The trick for these types of problems is to get common units. So let's figure out R. R is the radius. What is the radius here? 25 feet. Here's the thing. Anytime you have a radius, you always want to relate it to 1 radian. So 25 feet per 1 rad. The reason being, this is what the book does not go into, that book. In fact, you won't really find it in any book. Remember, we just did this. Theta equals S over R. That was the formula for our first R-plane formula. Well, if we solve for R here, we get R equals S over theta. So when the radius equals the arc length, then how many rads are produced? 1. Bink. So that's why we need to put 1 radian down there. The other reason is because notice our omega is in terms of revolutions. So we're going to need to do a conversion that takes revolutions to radians or vice versa, because those are the guys that are going to cancel. So if you just heard for the last minute there, all you need to remember is anytime you have a radius, please relate it to 1 radian. Okay, I didn't want to use the Charlie Brown voice because I don't want to get sued. Okay, notice that in part A we want to go to feet per minute. This is already in feet. Great, we'll leave that alone. In part B, to do something a little more exciting, but I'm going to erase this over here. Goodbye. And now let's work with omega. Omega tells us that the angle is rotating at 8 revolutions per minute. Since in part A we want to go in the units of time for minutes, then we'll leave the 1 minute alone. But the issue is that R is in terms of radians, omega is in terms of revolutions. We have to get them into 1 common unit, because that's what needs to cancel out, because we're going to just want feet per minute when we're all said and done. Doesn't matter where you put it, as long as you do it. So let's get rid of the revolutions in omega. Since we want to get rid of revolutions, where do I put revolutions in my unit fraction, top or bottom? Bottom, it has to go diagonal. And we want to go to radians up top. 1 revolution is how many radians? 2 pi. So you'll be needing this unit fraction, 2 pi rads per 1 revolution, or the reciprocal, anytime you have to go back and forth between revolutions and radians. Questions so far? Okay, multiply across, the revolutions cancel. So we'll get 16 pi rads per minute. Alright, since we're prepped for cooking, I'll just go back to V equals R times omega. Our R is 25 feet per 1 rad. Times our omega is 16 pi rad per 1 minute. What cancels here? The radians. And notice what we'll be left with is feet per minute. We'll have 25 times 16 pi. What is 25 times 16? 400? So we'll have 400 pi feet per 1 minute. So I'll just write it like this, feet per minute. That's the exact answer. What is that in decimal? Let's go to 2 decimal places. 1256.64 feet per minute. Part B, they want miles per hour. Now, we don't have to go through the whole thing. Let's start at the 400 pi feet per minute and go from there. However, if this were the original problem, then you would do your conversions from feet to miles while you're working on R, and you do your conversions from minute to hours while you were working on omega. There's nothing wrong with waiting to the very end, but it's a little bit easier if you do it all at once. So let's go from feet to miles. Feet is currently on top, so which means when we convert, feet will go downstairs, miles will go up top. I'll do the hard part. 1 mile is how many feet? Times. Minutes has to go to hours. What's our unit fraction?
1 minute, 6 minutes of 1.
Yep. So feet cancel. Minutes cancel. What I suggest you do is multiply across through the top. So we'll have 24,000 pi feet, 24,000 pi miles, right? Divided by 5280 hours. Now we were lucky our denominator just had a bunch of ones except for the 5280. Otherwise, if it was a little more complex, you would need parentheses in the numerator and denominator. We don't need that here. So if you want to do 24,000 times pi and then divide by 5280, and what do we get? How fast is he traveling? Is he going to fly off?
20.28 miles per hour.
That's not bad. He's Ico. Or Eco, however you pronounce it. Look at he's a boy with horns, and he gets banished from his village because he was born with horns.